It's now 198,988 miles. We have been test driving the vehicle with the same sensor, and what we can see we have there is a check engine light. Let's check that code real quick to see what it is. We can see we have P0 420 and P0 328 in the live scan and the freeze frame. So P0 420 is a catalytic converter code, and the 328 is a knock sensor code. There is no code associating with the oxygen sensor or the mass airflow sensor. This is the sensor with the paste that had the white paste. It was cleaned up to verify that it's a factory OEM mass airflow sensor. Now this sensor is working perfectly when compared to before in our tests. We are going to continue testing the other sensors to see if the ECU detects a mass airflow sensor code, a oxygen sensor code. We're going to switch over to this mass airflow sensor to see if it is a proper working device by running the engine and driving the vehicle for a few miles. Now I want to see how the vehicle engine will start at cold temperature, preferably early in the morning. So we could take a look at the temperature. We see it's cold. Let's start the engine to see what happens with the RPM. So I should have cleared the code from the previous mass airflow sensor, which is P0420 and P0328. I'm going to clear that code now, and we're going to try and restart to see how that engine starts. Normally, when you start the vehicle, you want that RPM needle to jump just above the 1000 RPM instantly. So that is something you will want to have when you're starting the vehicle. The engine is cold. You want that quick RPM for oil pressure. So we're going to test drive this sensor and see if it's a good working sensor. Right after starting the vehicle, we've got this code P0328, which is a knock sensor code. On the previous sensor, mass airflow sensor, we got this code at approximately 40 miles after driving with that catalytic converter code, which is P0320. So now I'm starting to think this knock sensor code is not a knock sensor issue. This might be related with the mass airflow sensor, since swapping of those mass airflow sensor that I showed you earlier exhibit or displayed a different driving pattern, also a different shift point in the transmission, and most important is the startup when the engine is cold. You want that needle for the tachometer to jump right above 1000 RPM as soon as you start the vehicle. So this is what we're getting with this sensor, which tells us it's a better working sensor when compared to all the others. But replacing it with a brand new one might solve this code P0328 and all the other codes that we have been testing and diagnosing in this video. So I'm going to change out that mass airflow sensor that we just placed in. We drove the vehicle for approximately about 30 miles because I had some mileage on there. Let's check the mileage. So we're currently at 199,000 and 6 miles. See that there? So let me swap that sensor. That is a good startup since the RPM jumped instantly above 1000 RPM and just sits back down to approximately 700, 750 RPM. So we're going to continue to drive with this new mass airflow sensor. It's not new, but it's used and it has the capability of new drivability. Let's try another start since that knock sensor code was cleared. So that's a good start looking at the RPM, which just jumps to 1000. While driving, it's now 199,009 miles. There we can see that catalytic converter code P0420, and we did not receive that P0328, that knock sensor code, which is critical to eliminate so the vehicle could have 100% performance. Now that we did not see that code, again, because you can see in there it says in the frame 1 of 1, we're going to continue to drive and see what happens. Most likely that knock sensor code is related to the mass airflow sensor. So just because you're going to change a knock sensor, you're going to think you're going to eliminate that P0328 is not likely. So you might want to change the mass airflow sensor before doing so. So there we have a flashing check engine light as I'm talking to you, and that's a random cylinder misfire that is most likely coming from the mass airflow sensor, because we did not have this issue before. So I did a rescan and I detected, I got that code P0300. That's that flashing SCS light that you just saw, and that's the 420 that's set previously. Most likely we're going to have to change this mass airflow sensor and see. But once we get a brand new mass airflow sensor into this vehicle from Nissan, a genuine OEM, all these issues are going to disappear because we have eliminated for it to happen in the circuit. There was a short in the circuit for all these sensors: the mass airflow, the oxygen sensor, and other sensor related to those sensors. All have the same ground circuit. So let's take a look at that. Let me show you. When we take a look at the factory wiring diagram, we will notice this F11 where that hand is pointing. F11 is a common ground. It's a junction ground with all the sensors, the downstream, 2 downstream oxygen sensor, and other sensor are all ground at F11. This is the knock sensor. You can see it's also ground at F11. Also with the ECU is ground on this circuit. So here is a test for the knock sensor, which is 500 to 620 ohms on its reading. This is also a diagnostic for trouble code 420. Most of the time it's the catalytic converter is bad and it needs replacement. So that will be taken care of. This is the TPS sensor with another F11 ground with the ECU circuit into that ground. So many sensors are grounded into this F11. This is the camshaft position sensor that's inside the distributor. We will have to check this ground location and make sure it's clean for continuity, because if this connection is not connected solid, it will cause a malfunction in various sensors like we are experiencing in our previous video. Once this connection is clean, now looking at the engine compartment, you're going to find that ground that needs to get clean. It's right here. Let's take a look at that ground connection for all those sensors. That's F11 on top of the intake plenum manifold. And once you clean that area out, you're going to find all these wires going to it. There's 4 wires. There's a black wire with a red stripe, a black wire with a yellow stripe. Actually, there's 2 black wires with yellow stripe and 2 black wires with red stripe. So when you take a look down in there, you can see that connection is right here. So you're going to have to take that bolt off. You will also have to clean the mating surface. That will be the aluminum surface where the terminal contacts the aluminum. So what you have here is 3 different metal in one area. The terminal itself is a copper. The mating surface is aluminum, and the bolt is steel. This will most likely be prone for corrosion due to moisture, the heat and cold situation. You're going to want to take attention to that. So now we're going to try test driving the vehicle with this aftermarket new mass airflow sensor from AutoZone. Take into account when we started the retest on all the mass airflow sensor, this terminal here was clean before our second test began. On the first test, we were not aware of this terminal connection and its corrosion ability to disconform with computer logistics and the sensor. That sensor from AutoZone we had to remove. Did not get a check engine light, but it's causing drivability issue. Vehicle was shut off when you slow down. So this is just telling us we need to get a factory OEM mass airflow sensor. This is one of the original sensor from the previous test that was done with the check engine light to verify codes or circuit malfunction or intermittent problems. Now that the ground circuit has been fixed for this sensor to perform to its best, in the previous test, this is the sensor that displayed P0 138, that's air fuel ratio, sensor 1 bank 1, and P0 152 air fuel ratio sensor bank 2 of sensor 2. We also had P0 328, which is a NOx sensor code, P1163, which is a oxygen sensor on the bank 2, and P0 300, which is that flashing service engine soon light. So we're going to take a start at this sensor first thing in the morning, and what we want is to make sure we have the engine temperature is at its coolest. What we need to look at is the RPM on the dash cluster. When we start this engine, or should you start the engine, that RPM needle must instantly jump above the 1,000 mark. That will be that 1. Anywhere between 1,200, 1,300 RPM. That's where you want the engine to start at. This is going to let you know that the vehicle is equipped with a perfectly working mass airflow sensor. Also, when driving the vehicle, pay attention to the shift pattern on the transmission, mostly between first gear and second gear. Sometimes when the mass airflow sensor is in a fail state or experience intermittent problem, such as a corroded or non-functioning ground circuit, that shift will be very soft. When you have a perfectly working mass airflow sensor, the shift between first and second is going to be a hard impact, solid shift. So you have to pay notice to that also. So we have turned the key on for a few minutes now, approximately 2 minutes, 3 minutes. And we have allowed the fuel pump to prime the rail system with approximately 36 psi of fuel. Since the vehicle is such a high mileage, approximately 199,112 miles, it will require a second cycle of the key to get that fuel pressure up to 36 psi. We're not going to do this in this test. Now understand, since we've been sitting for that 3 minutes, the pressure could also bleed off. So let's take a start at the engine and make sure that RPM jumps above the 1,000 mark. So that is not a good start. Why that is not a good start is because the engine is not spinning fast enough for pulling that cold oil up into the engine. Once you can get that fast start where it's at right now, that's a sign that the oil is immediately rushing to the valve trim, lubricating the engine. When it's in its most critical state, that's cold, so that's when you really need that oil. A startup that we have just seen there is not good. So let's turn the engine off and start it again. So that is a startup we want first thing in the morning. Now, the only thing we have to do different to maybe experience that startup first thing in the morning is to cycle the key on and off 1 or 2 times to build that optimum fuel pressure, like I said before, which is 36 psi. Then we will be successful at having that RPM. So we're going to try that again tomorrow, and we're going to cycle the key a few times to see if we can correct that spark. So we're going to take the vehicle for a test drive, see what code this sensor display or is still in the circuit, still malfunctioning on the engine, and we will deal with it from there. It's now 199,171 miles since we have completed all our test drive on the mass airflow sensor. What we want to take a look at is, you already see that check engine light is displayed, but it's not for codes relating to the oxygen sensor and the mass airflow sensor. And also with this mass airflow sensor, which is a used factory OEM mass airflow sensor, I think it has approximately 60 miles on it, is best in working condition, maintaining idle, not shutting off, good shift on first to second gear for the transmission. Now another thing you need to know about when this check engine light is on, the computer is going to operate in a mode called limp mode. So there's a limp mode and a loop mode. In the loop mode, that's when the check engine light is not displayed. That's when the ECU rely heavily on the sensor from the engine for information to accurately tune the engine for optimum performance and fuel efficiency. If that check engine light is to remain on, that means the ECU will operate in a limp mode, where it's a pre-programmed mode based on the temperature, the cooling temperature sensor and the intake air temperature sensor. The ECU will know where to base its fuel and ignition timing for maintaining engine operation. So the goal is to always get rid of that check engine light, regardless of which sensor is malfunctioning or circuit is malfunctioning on the ECU system. Now that we have taken care of that, let's take a look at the codes that we have derived from this sensor. Already I'm going to tell you it's P0328, that's the knock sensor code, P0300, which is a random cylinder misfire, and that's about it. So that's the knock sensor, and also random cylinder misfire, like I said. But okay, so you can see on the ECT temperature, that's approximately 177 degrees Fahrenheit, and the temperature was lowered. Normally this vehicle will operate around 210, 220 degrees Fahrenheit. So I lowered the temperature since the mileage is at approximately 200 miles. it's best to do so. So here we have our code P0300, multiple cylinder misfire, and 328, that's knock sensor, and both of those codes are in the freeze frame and live data scan. So it's showing 104, 204, 304. In order to rid that P0300, which is the random cylinder misfire, it's associated with the mass airflow sensor. And the reason we know this is because when the check engine light is flashing and the random cylinder misfire is taking place, you're not going to feel a physical stumble on the engine or a misfire from the engine. The engine will run normal, but you will get that random cylinder misfire, which is telling you right away this is a mass airflow sensor problem and not spark plug wire, distributor, or anything related to the physical ignition circuit. It's just a malfunction happening inside of the mass airflow sensor, semiconductor, and the microchip. Remember, the mass airflow sensor, all the other sensor reports to the mass airflow sensor, and the mass airflow sensor is what determines how the ECU is going to perform with the engine. So replacing the mass airflow sensor is something you're going to want to do the first time you get a check engine light pertaining to the oxygen sensor, the knock sensor, and TPS sensor, camshaft position sensor. Those are all connected to that ground circuit that we clean on top of the intake planium manifold. Also, the ECU is grounded to that ground circuit. Now, the best thing to do with that ground circuit is to remove it from the top of the planium and run it directly to the negative side of the battery. That will eliminate a lot of problems in the future. Let's try a cold start. I'm looking at the coolant temperature sensor. Let's see where the RPM needle sits. So that is definitely not a good start. It takes a while for the oil to get up in top of the engine with that kind of RPM. So this is telling us that that mass airflow sensor is not really good for startup. Might be good for driving and while the engine is hot. Now we can see the RPM is where it should be for optimum oil pressure in cold condition, but this is still not good. So we have P0300 and P0328 stored into the computer. We're going to keep it on, continue driving the vehicle to see if we experience issue with drivability, stop and go condition, if the vehicle should shut off or anything like that.